This is a video for AQA Further Pure Mathematics, Algebra and Graphs, section 4.3, which considers graphs of y equals 1 over f of x. Well, the idea then is to consider 1 over f of x if we already know what the graph of y equals f of x looks like. So here's one example where we've got a function. It doesn't actually matter what the function itself is, but we're going to consider how do we then determine what the graph of 1 over x might look like. Well, there are one or two quite straightforward things that we can do. First of all, if we have the point 0, negative sixth on the graph of f of x, then y is 1 over negative sixth must be equal to negative 1/6. So we can see that it must cross the axis just below 0 there on the y-axis at indeed negative 1 over 6. The other quite crucial points are when the function itself, f of x, is equal to 0. Here and here. So where the function crosses the x-axis. At those points, 1 over f of x will be 1 over 0. So that must mean that we end up with asymptotes at the values given by x equal to negative 3 and x equal to 4. Once we've decided that, we can look at the nature of the function y equals 1 over f of x as it approaches these asymptotes. Well, where the function f of x is positive, then 1 over f of x must also be positive. So that means it's going to approach this asymptote, first asymptote, at the positive end, and also leave the second asymptote at a positive value. To the right of negative 3, the function is negative, so therefore our 1 over x must be negative. Likewise, at the left of, or so below, x is equal to 4. Well, that's probably about it for the asymptotes. What happens as x gets larger? Well, we can see here that as x is getting large and positive, then f of x is getting large. So 1 over it must be coming down towards 0, asymptotic to the x-axis, in other words. At the other end, the same thing is happening. As x gets large and negative here, then f of x is getting larger and larger, so 1 over f of x must be getting smaller, and it's approaching the x-axis from above. One other thing that's worth looking at is when the value of f of x is equal to 1, because if f of x equals 1, then 1 over f of x is also equal to 1. Likewise, for f of x equal to negative 1, 1 over f of x must be equal to negative 1. So on the first graph we can see that x is equal to, well, around about here, just under negative 3. Then we have f of x is equal to 1. So that must give us a value here, and at the other side of the graph, just above 4, we have a value of 1. And negative 1 is at this point here, so the graph will be negative 1 here, and likewise at the right hand side, f of x is negative 1 just below 4, so 1 over f of x must be negative 1 just below 4. Now that gives us an indication of how steeply the graph actually rises from those asymptotes. Remember, it is only a sketch. So let's try and do our best with our sketch. It's going to go through that point and then rise very, very steeply. The asymptote, the other side, it rises up quite steeply to -1. It never gets positive between the asymptotes, so it must be quite flat there, and then comes down that side of the asymptote, and then finally looking something like that. Now this has been drawn admittedly with a computer graphics program. You don't need to do that, you're looking for a sketch, but as long as you get the asymptotes in the correct place, so that's when f of x is equal to 0, we have asymptotes, and you have the 1 over f of x positive in the correct regions and negative in the correct regions. So it's useful to check those values when f of x is equal to 1 or -1 to give you an idea of points that the 1 over f of x is going through. And then we look at where it approaches the x-axis, or what happens when f of x gets larger and larger, then 1 over f of x is getting smaller and smaller. So in general then, we consider the graph of y equals f of x. Firstly, look for points where f of x is equal to 0, and therefore we will have vertical asymptotes. Then consider the behavior as f of x approaches infinity, so therefore 1 over f of x approaches 0. If there's an intercept, then y equals 1 over f of x has an intercept at 1 over that value. And also, there's the if f of x is equal to 1, then 1 over f of x must also be equal to 1. And if it's -1, then 1 over f of x is equal to -1. Well, that completes this video on looking at graphs of y equals 1 over f of x. In the final video of this series, we'll be looking at graphs with functions that produce oblique asymptotes.